Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun differential equation. So I have y is equal to y prime plus y double prime plus y triple prime plus y quadruple prime, etc. And obviously y prime represents dy dx. Y double prime is the second derivative of y with respect to x. So our goal is to solve this one. It looks pretty terrifying, but I promise it is doable. So if you want to give it a shot, go ahead and pause the video and try it on your own. Otherwise, let's go ahead and jump into a solution. Okay, so what I'm going to remind people, so obviously y prime is equal to the derivative with respect to x of y. And I can also write y double prime is the derivative with respect to x of y prime. And I can continue this down the line, and I could write y, the third derivative of y with respect to x is just the derivative with respect to x of y double prime. And because of this, we can take a nice little shortcut. So I can write y is equal to y prime, and then let's make use of these guys. So I can call this the derivative with respect to x of y prime plus y double prime plus y triple prime, and so on. And what I notice here is what I've just done is I've rewritten it, and I have this guy, which just so happens to be exactly the same as this expression up here. So instead of writing that as y prime plus y double prime, etc., I could just write that as y, because I know y is equal to everything there on the right side. And that's going to be the trick here that gets us toward a solution. So I can rewrite my expression now as y is equal to y prime plus d dx of y, which is just y prime plus y prime, which is 2y prime. So my expression that I actually have to solve, my differential equation, is just y equal to 2y prime, which is 2 dy dx. So let's go ahead and use our notation here. And we're going to write this so we can do separable here. And we're going to have we're going to have dx over 2 is equal to dy over y. And we'll just integrate both of these sides. So let's integrate the left side and integrate the right side. And what we're going to end up getting is x over 2 on the left. And I'm going to go ahead and put the constant over here. So I'm going to add that constant over here. And I'm going to have that equal to the natural log of y on the right side. Next thing we're going to do is we're going to raise both these sides, e, and that's going to give us, kind of rearranging a little bit, I'm going to have y is equal to e to the x over 2 plus c, which is obviously e to the x over 2 times e to the c. So I'm going to rewrite this in a final form as y is equal to some constant, I'll call it c0, e to the x over 2. And that is actually going to be our nice little solution to our above expression. And you'll notice that the reason this is the solution is when we pull out the derivatives, I'm going to have this 1/2, then I'm going to have 1/4. So I'm actually going to have a geometric series. And remember that the sum from n equals 1 to infinity of 1/2 to the n is equal to 1. So that's why I'm going to end up getting all of those derivatives is just going to add up to the original term on the other side. All right, so I appreciate you joining me for this problem. If you enjoyed it, please like and subscribe. If you have an idea for your own video, please submit it to thinkthriceproblemsolving@gmail.com. And as you're working through problems on your own, think once, think twice, and if you ever really get stuck, think thrice.